Let's understand about GD&T symbols used for cylindrical workpiece. GD&T are standards used on workpiece drawing, implying which one workpiece fits correctly in other workpiece during assembly after manufacturing. It is all about fitting of one workpiece correctly in other workpiece using bolts in an assembly. Geometric dimensioning and tolerancing is represented in form of symbols in engineering drawing. Let's learn about different symbols used in geometric dimensioning and tolerancing, or GD&T. Runout. Runout is how much cylindrical surface vary with respect to datum axis when it rotates 360 degree around datum axis. Let's refer drawing to check runout. It is represented by this symbol. As per drawing, runout tolerance limit is 0.05 mm. Now, check the runout for cylindrical surface with respect to datum axis. Now, measure runout of workpiece using plunger dial. To do this, manually rotate the workpiece. Reading on plunger dial can vary between 0 to 0.05 mm. As per drawing, runout tolerance limit is 0.05 mm. So you can conclude that runout is within tolerance limit. Straightness. It is a condition of workpiece where one line of surface must lie in a straight line. Now, refer drawing to read straightness. It is represented by this symbol. In the drawing, straightness tolerance limit is 0.03 mm. Now, to measure straightness of cylindrical surface, hold workpiece between centers of bench center. Keep plunger dial on the surface of workpiece. Then, move plunger dial along the length of workpiece. Reading on plunger dial is varying between 0 to 0.03 mm. As per drawing, straightness tolerance limit is 0.03 mm. Therefore, you can conclude that straightness is within tolerance limit. Circularity. It is a condition of workpiece to control roundness of circular surface. Now, refer drawing to read circularity. It is represented by this symbol. In the drawing, circularity tolerance limit is 0.03 mm. First, keep cylindrical workpiece on V block. Now, keep plunger dial on the surface of workpiece. Rotate this workpiece on V block. Reading on plunger dial is varying between 0 to 0.03 mm. As per drawing, circularity tolerance limit is 0.03 mm. So, you can conclude that circularity is within tolerance limit. Cylindricity. It is a condition of a surface in which all points of the surface are equidistant from a common axis. Now, refer drawing, to read cylindricity. It is represented by this symbol. Cylindricity of cylindrical surface should be within 0 to 0.03 mm. To measure cylindricity, keep plunger dial at one point on cylindrical surface. Then, rotate this surface, and measure reading on plunger dial. Repeat this for 2 more points on the workpiece. Also, measure the plunger dial reading for those points. As per drawing, cylindricity tolerance limit is 0.03 mm. Therefore, you can conclude that cylindricity is within tolerance limit. Concentricity. It is a condition in which 2 or more cylinders have a common axis. Now, refer drawing to read concentricity. Concentricity is represented by this symbol. As per drawing, concentricity tolerance limit is 0.02 mm. Here, one cylindrical diameter should be concentric, within 0.02 mm, with respect to the datum cylinder, A. Consider that workpiece has 60 mm diameter at one end, and 100 mm diameter at other end. 60 mm diameter surface is kept on V block. Plunger dial is kept on 100 mm diameter surface. Then, reading on plunger dial is varying between 0 to 0.02 mm. So, as per drawing, concentricity tolerance limit is 0.02 mm. So you can conclude that concentricity is within tolerance limit.